All right, everybody. Today we're going to zip through what will hopefully be a short and sweet version of basic area formulas. So you can take notes on just the formulas, or you can follow the examples. Feel free to skip around in here wherever you need to. So first shape that could be on your note sheet is area of a rectangle. We're also doing perimeter, which is all of the outside edges. So though there's a formula right here, you can actually cross that out and just say all add all outside edges. It's the easiest way to think of perimeter. So for the example that's here, we're going to use the area formula here, length times width. Now we happen to have a square, which is a rectangle. So for any rectangle, you can use these formulas that are here, including squares. So if it says BC is 10 feet, that means this is 10. And this is also 10 because it's a square. So my area is going to be 10 times 10, which is 100. Don't forget your units, feet squared. Now, if we do perimeter, we have more 10s over here, and we could do perimeter is 10 plus 10 plus 10 plus 10, or 10 times 4, which is 40, and in this case, it's just feet because it's not area, it's perimeter. All right, next. Here's a parallelogram. Again, we have these formulas that you can copy down. A parallelogram is just a modified rectangle, essentially. So you're just going to use the base and the height right here to find the area. And then, as with the previous example, for the perimeter, you're going to add all outside edges. So if we look at our area of this example, it says that AD is 19. So let's label that. And we have a BE, which is 4 right here. So my area on this one is going to be easy. It's going to be 19 times 4. In my head, because I don't have a calculator handy, I would do 20 times 4, which is 80, and then subtract 4, so 76 inches squared. Now on this one, the perimeter is going to be a little bit more difficult because we don't have this edge over here, which is the same as this edge. So on this one, perimeter, we're going to have to say not enough information. Now, if we had a little bit more information over here, so if we knew what this was right here, then we could use Pythagorean theorem right here to find this piece. But we don't know what this is either, so that's not going to help us. All right, so area of a triangle is 1/2 base times height. And that's how most formulas will show it. You can also say base times height divided by 2, depending on how you've been taught in the past. Now, the reason I chose this example is because the height is always a little bit different. So if we're looking at a right triangle, then the height is actually one of your legs. If we're looking at a standard triangle, we have the base here and the height here, which is how you're probably used to seeing it. But if we have an obtuse triangle, then my base is an edge of the triangle, and the height is actually the perpendicular piece that's outside of the triangle. And as with all other shapes, for the perimeter, we want to add all outside edges, which will be different for each of these triangles that are represented here. All right, so here's one example. Let's find the area and perimeter of this, assuming that we have enough information. So ZX is 12 yards. That's going to be this. And WY is 7 yards. So that's going to be a 7 yards here. So my area is going to be 12 times 7, which is 84 yards squared. Now, in this particular case, we don't necessarily have quite enough information, but if we make some assumptions here, if we assume that this piece is congruent to this piece, we could say that this is 6 and this is 6, and we could find the outside edges here. Now, don't make that assumption unless your teacher says it. I just would like to go through an example that includes Pythagorean theorem. So if we want to find this side here, we could do 7 squared plus 6 squared equals x squared. So 49 plus 36, x squared. Let's do 49 plus 36 is 85. So 85 equals x squared. And when we square root both sides, this is going to be about 9.2 based on the fact that the square root of 81 is 9. So if we call this 9.2 and 9.2 over here, because we have two congruent right triangles built into this one triangle, then we have a 12 here, a 9.2, and a 9.2. We do not use the 7 for the perimeter because it goes through the middle. So 12 plus 9.2 plus 9.2 is going to be 18.4, 30.4 yards would be the perimeter. All right, so here is a trapezoid. In this particular formula, you might have seen a teacher in the past call this base 1 and this base 2, which would modify this formula here to be base 1 plus base 2. So you can use whichever formula makes the most sense to you. I just liked these images. And we have an example over here. So we have area of a trapezoid is 1/2 of the height. I like the base 1 plus base 2 because that's how I was taught. So let's use our numbers that are given here. So NL is going to be this piece right here. That's 14. We have JK, which is 9. And then we have JM, which is 7. So if we use this area formula over here, my area is going to be 1/2 times my 7, and then times my base 1 plus my base 2. And now we just follow PEMDAS to go through this. So we have 14 plus 9 is 23 times 7 and times 1/2. And 7 times 23 is 161. So we have 1/2 of 161. And 1/2 of 160 would be 80, so my area is going to be 80.5 feet squared. Now in this one, again, we are missing these outside edges here in order to find the perimeter, and we don't have enough information on this one. All right, last but not least, we have circles. So circle formulas. The perimeter of a circle is actually called the circumference. Has a special name. And it can be calculated as pi times diameter or 2 pi r. And 2 times the radius is the diameter. So these formulas are actually the same. It just depends on what information you're given. And then we have our area formula over here of pi r squared. Now, some teachers will expect you to leave your answers what we call in terms of pi, where we don't actually calculate the pi because it's a gross decimal. and other teachers will want you to round to a certain amount. So we will do the perimeter using, leaving our answers in terms of pi, and then we will calculate the area where we actually calculate. So my circumference here is going to be pi times diameter, but we don't know the diameter here because I'm given that my radius is 5 feet. So I want to use my 2 pi r. So circumference is going to be 2 times pi times 5. And I can multiply the 2 times 5. So my circumference is 10 pi. And we have still units in feet. Leaving the pi on there makes it just a little bit of a cleaner calculation. All right, so area is my pi r squared, and my radius is 5. So if I were to leave this in terms of pi, I would have area is 25 pi, and I could be done. Or I could punch that into my calculator as area is 25 times 3.14, or hit the pi button in your calculator, which is what I'm going to do. So 25 pi is 78.5398. So depending on the rounding, we may round any of those. Oh, I forgot my units, feet squared.